Thanks everybody for joining today. I just want to also thank the organizers for putting all this together, bringing all these great people into the same space and giving us opportunity to talk about robotics and the advancements that we're seeing in the field. I want to start out by introducing myself. I'm Michael, one of the co-founders of Kabam Robotics. I've been working in robots for a long time, most of my career, about 15 years. Started out doing subsea robotics. So when we were building these machines, they're essentially submersible robots that would go into the deep ocean, right? And these things would be on a fiber optic and powered tether that would lead up to a boat. And it was primarily controlled by a human. It was about 95% teleoperated. After spending some time in that field, I moved over into military applications. So these were things like reconnaissance robots, robots for demining, and bomb disposal. So we were starting to see greater levels of autonomy with these robots, but there was still a lot of human inputs. Then I shifted over into deploying robots into logistics spaces here in Singapore. So this is where we started to see robots in more uncontrolled environments, right? I think traditionally robots were kind of relegated to factories, being sat on a production line. All of the input variables are very controlled, right? And so that's probably one of the things that distinguishes automation from robotics is the ability to handle these variable conditions, unpredictable situations and scenarios. So when I was in the logistics space trying to deploy these robots, we saw this challenge of having dynamic and unpredictable environments and how that would affect the robot's operation and efficiency, which is what led me to start the journey of Kabam Robotics. And it's been really exciting to work in the field and see the advancements over time that have led to robots being able to operate in these public spaces like the ones that Kabam Robotics operates in now. These are like shopping malls, government buildings, public spaces where you really can't control the environment. You have people coming and going. They're very human-centric spaces, and they need to be. So we don't have the opportunity or the luxury of modifying those spaces to accommodate the robot. So we have to rely on technology to make sure that the robots can operate in these spaces. And so that's a big part of what we're going to talk about today. The challenge that Kabam is trying to solve right now is the labor availability crisis. So I think we've all heard about the age wave. We see aging populations in all of the developed countries. In our sector, security and facilities maintenance, we see a lot of our customers saying that it's simply impossible to hire for the roles. And of course, this is driving up the price of that role, the cost that you have to pay somebody. And it's also creating bottlenecks in terms of their ability to satisfy their customers' needs. So we see technology as a big part of what can solve this problem for industry. So in Singapore alone, right, we can see that the average age of a security officer is 54 years old. And so this is nearing retirement age. There's also certain health-related issues that limit what they can do, right? So if you have a large perimeter around a building and you need somebody to walk that perimeter, that's not as easy for somebody that's approaching retirement age as it is for somebody that's young. And this is another challenge that our customers talk about is that the perception of these roles is very difficult to attract talent. People don't see this as a future that they want to pursue. And so with all of these factors, it makes it very difficult for them to hire. So with technology, we can bridge the gap between the labor that they need and the labor that they have. So the way that we approach this is essentially combining our fleet of robots that you see here on the left with our Smart Plus mission control system on the right. So you can see here, these are robots you might have seen around Singapore. We've got an outdoor unit and an indoor unit, and then you see some on the left that are built for a company called Certus here in Singapore. So they essentially bought the design. So we make those exclusively for Certus, but the other two units are available on the open market. And then all of these robots are controlled through the Smart Plus mission control system, which we'll get into a little bit more depth later in the talk. So Colab is a unit that you might have seen here on the top floor. We've got this unit here for the show so you can interact with it, you can play around with it and see what it does. Essentially, we have a surveillance platform which can do things like security patrols. It can go around inside of a building and see what's happening. It can report on what's happening, generate reports about what it sees, similar to what you would see a security officer doing. We achieve this by essentially giving the robot LiDAR at the bottom so it can see where it's going. We have ultrasonic sensors, so transparent objects are visible to the robot. We have a camera array at the top, which we use for all of the collection of video and picture data. So this can see people's faces. It can see if doors are open. I'll get into more about the computer vision that is included in the robot. This can actually be raised to 2 meters in height. So this is something one of our customers said was really important for them, because when these robots get into public spaces, there's people all around. So the cameras will get occluded by the people, and then you can no longer see what's happening. So being able to bring that camera up to 2 meters in height allows us to see over the heads of the people in the crowd and give a better visibility to the people in the command center or to the robot itself, so it can perform its computer vision tasks. We also have a public address system on this robot so that it can essentially broadcast messages, talk to people, and people can also talk to the robot, which is something that we do with a concierge function. I'll talk about a bit more later. We also can do two-way communication. So if you have, say, a remote information officer or somebody that can help people in the environment, that person doesn't need to be co-located. They can be anywhere in the world, and they can help people in the building that might need some kind of assistance. So here we can see Halo, which is our outdoor unit. We didn't bring this today, but it's got a lot of the same functionality as CoLab. We still have a 360-degree camera array. We still have an array of LiDARs for the robot to understand where it is in the environment, to avoid obstacles and so forth. And the entire system is built with all weather, all terrain conditions in mind. So if we need to go into rain or snow, we're able to do that with this robot. We can even charge when it's raining because we use an inductive charging system to transmit power into the robot, the same way that your phone would use inductive charging, essentially. And then, of course, with the large wheels at the bottom, we're able to go over curbs and other rough terrain. So this is all combined with Smart Plus, and this is something that I think is really interesting because it leverages a lot of the connectivity and cloud technologies that have come to the fore in recent years. We heard from Amazon earlier, and we leverage a lot of the same technologies that they talked about in their discussion. So we're able to do things like device-agnostic robot operations. That means that not only our robots work on this system, but other robots can be connected through the inclusion of adapters and so forth. So this is great for a customer because it gives them a single interface to control all of the robots in their environment. We're able to generate these reports and alerts so that people can see what's happening on the robot. This is particularly important for the applications we work in, which is facility and security, facilities management and security. So that we can generate tickets for those teams to react to what's happening in the space. We also use this to connect the system to video analytics that can be performed either in the cloud or on the robot itself. And we are able to interoperate with other systems in the robot's environment, things like lifts, auto doors, and so forth. So all these features are really important because we're operating in these public spaces, which tend to be very dynamic and human-centric. We can't easily modify this space, as I mentioned, to accommodate the robots. So we have to rely on technology to overcome this. Part of the solution here is some of the navigation advancements that have come about in recent years. Things like visual semantic navigation, essentially using a camera for the robot to understand its environment where it is, using things like homography and landmarks. So this allows the robot to use a lower cost sensor to determine its position and to plot a course to its destination. This also allows for better performance overall without adding exotic hardware to the robot, which helps us keep the cost down. So here are some of the features related to the ticketing and the reporting. So these are really important when we talk about operating in public spaces because we have these connectivity technologies we can leverage to understand where the robot's facing challenges. So we gain these insights. We can easily update the mission or the maps to accommodate whatever it is that's causing operational inefficiencies or causing the robot to fail in the environment. This is very common in public spaces because things are always changing and people are moving through the space in unpredictable ways. So being able to see that that's happening, get a report on exactly what's happening, and then modify the robot's instructions to accommodate that is very important. So here's a little bit about the computer vision functions that we perform. You'll see on the left some stuff that's going to be very commonplace that you've probably seen before, things like people counting, facial detection, abandoned object detection, license plate detection. And then on the right, you'll see we have the ability to detect faulty light bulbs, overflowing dustbins, faulty infrastructure, liquid spills. These are really important for facilities management. So, if somebody wants to know about a light bulb being out, then the robot's able to tell them. We don't have to rely on a security officer to identify that and report it to maintenance. The robot can identify that itself and then create a maintenance ticket through the integration to the work management system that they would have at that site. So we operate a lot of this in the cloud. And so there's going to be certain times where this is a problem, right? We have latencies involved. A lot of what we do, the latency isn't a big deal, right? We don't have a stringent latency requirement. So whether it happens in 5 milliseconds or 5 seconds, there's not really a big difference in the perception of the quality or performance of the robot. On the other hand, facial detection needs to happen more immediately in some cases because we want to react to a specific person in the environment or even talk to the person. So if you have a 5-second latency in that sense, you're going to get a performance problem. So we operate some of this on the edge, but a lot of this we operate in the cloud. And there's a lot of opportunity in doing this. We're able to run many, many different kinds of models. And we're able to run these simultaneously in many cases without having to add a very high-spec computer to the robot. So this is one of the advantages of operating with cloud and connectivity technologies is that we can deploy hardware that might not be the most cutting-edge stuff and still do some really impressive things through the connectivity that the robot has. So some interesting things happen when we combine these computer vision functions with large language models. I think it's safe to assume everybody here is familiar with ChatGPT. It's in the news. So systems like that are interesting because they function on the foundation of language. Language itself was developed by humans to talk about the world around us. It's essentially an abstraction that in many ways reflects and encodes understandings about the physical world that people have, logical assumptions and so forth. So large language models leverage this abstraction to allow machines to generate intelligent responses or take intelligent actions. We're building a system called REMI, which essentially connects to a system like ChatGPT. And it can do some really interesting things, even stuff that surprises us. I think there was one anecdote where we had a system where we can tell, oh, your battery's running low, go back to the dock. So it goes back to the dock. Pretty simple. Raise your boom. It'll raise the boom. In other cases, you might say something like, I'm thirsty. And the robot will actually say, well, follow me to the pantry. We have food and drinks there. This is a response we didn't pre-program. It's a response that the robot kind of invented because it understands the labels that are on its map. It understands what a pantry is and where drinks are and what thirsty means. So these are all very interesting developments. I think it's still early days in terms of finding applications for this. But it goes further. I mean, you can ask the robot to go to an entrance, tell me what you see. It'll figure out where the entrance is. It will go there, and it will look at the entrance and give you a description of what it sees and maybe send you a picture if you ask for that. So these are all really powerful applications that we see emerging with the inclusion of large language models. And I think it's a really exciting time to be in the field. So we actually have a couple examples where we're leveraging this technology right now. Here's an application where we're deploying the robot in a showroom. So MIST is essentially a showroom where people can see property. And when the robot is operating there, people will come into the room and it will identify that a person has entered the room through the facial recognition and greet them. They can ask the robot questions about the showroom and it will give them answers. We also operate an application on the tablet so that they can retrieve information about the site and get a better understanding of what is available, the facilities and so forth at the site. And here's another application at the Lifelong Learning Institute. So this is another public space, and we're seeing that in this scenario, the public is able to retrieve information about the upcoming schedules for courses and so forth. So if you're there to learn, you need to know when your class begins and so forth. So the robot's able to provide that information to people that are in the space. We've also got this integration. I'm not going to spend too much time on this because we are running a little low on time. But essentially, we have applications where we can go deliver items with the storage on the robot. There's a storage compartment where you can place something inside it. We'll take it from one part of the building to another. Our connectivity allows maintenance tickets to be generated in scenario 2. For example, we identified a faulty light bulb. The maintenance team can then be informed of the location of the light bulb, a picture of the light bulb, and the time that it was identified so that they can incorporate that into their workflow. We can use the same alerts to let people know when events of interest have occurred. For example, maybe somebody left an abandoned bag behind or somebody's parking illegally. So that's a case where you'd want a security guard to go and interact with that to investigate the situation or to talk to the person that's parking illegally or otherwise manage the vehicle. So here we have a little bit of information about work that we've done with RMF, which I think is something that a lot of people here are familiar with. We're leveraging RMF to interact with some of the infrastructure inside of the buildings where we operate, things like taking lifts and opening auto doors. So this has been a really exciting project for us. We're able to now work with all these different lifts that you see here, Kone, Otis, Mitsubishi, and we're able to also contribute back to the community by the development of adapters and so forth so that other robots can leverage the tools that we've built to interact with these building infrastructures. Here's just a list of some of the customers that we work with. It's really not meant to be a brag in this scenario. I just wanted to show how much we've progressed in terms of bringing robots into public spaces. I mean, you're going to notice that these are all companies that operate in these public buildings: SMRT, Certis, Thomas Foods, which is a grocery store in Australia. And we've gone a long way in terms of expanding. So leveraging connectivity and cloud technologies has allowed us to scale in a way that wouldn't have been possible just a few years ago. We're now operating in a bunch of different countries. We're in the US, we're in South America, Taiwan, Hong Kong, Singapore, and Australia. And this has all happened in the past 2 years. So we're really excited about the way that things are progressing and the way that technology has allowed us to scale the operation and to do this in a way that isn't bottlenecked by problems of the deployment or problems of different infrastructure and resources being unavailable. So leveraging these advances in technology has allowed us to operate in spaces that would have been very challenging in the past and are now accessible to robots. So with that, I'd like to close things out, open it up for questions. I think we're just on the mark at 11, so I haven't left too much time for Q&A, but yeah.
Thank you, Michael, for the talk. All right, now let's open the floor for questions. All right. May we have Mike?
Hello, yeah, I'm Ding Shing. Thanks for the sharing. From Science and Tech Policy and Plans Office, we have a collaboration project with Kabam at the JTC Summit. Yeah, thanks for contributing.
It's a great site.
Robot. Yeah, it's very exciting. And the JTC Summit, once we are done with that, it will be the first public sector building that is robot ready. And we can deploy Kabam's robot and other cleaning robots in the building.
It's been really exciting.
Question. Yeah, I'm interested to know about the Halo. Are you looking at some kind of because in a dynamic environment, outdoor environment, the robot may come across certain obstacles like tree branches or cardboards, which to a human being you know that you can bash through, right? But to the robot, it may think that it's an obstacle. Without interacting with the object, you don't know whether it's whether you can bash through, right? The robot wouldn't know. Are you looking at a version where you can allow some form of teleoperation or remote teleoperation where a human being can help the robot and control a robot out of trouble, either control a robot to bash through those obstacles or basically get help? Yeah.
That's a really good question. And it's actually one of the first things that we built because, as you mentioned, right, operating in these unpredictable environments where it's not certain how you should behave in different scenarios, it's important to have the ability for a person to override whatever the robot's assumed behavior is. So that was one of the first things we built, was the ability for a human operator to be alerted to some uncertainty. about the environment and then to give the robot an input. What should it do? So we can do that either by direct teleoperation, something we call safe teleoperation, where we still respect all the sensors on board the device. We don't run into things unless there's an additional override. But usually we don't need to do that. We can simply drop a pin on the map and say, go here and then go there. Or we can maybe move its waypoint out of harm's way. If, let's say, something has changed in the environment where a waypoint that was safe in the past is no longer a good waypoint, we can modify that through the platform. So yeah, we do address a lot of these scenarios using teleoperation or otherwise bringing a human into the loop of the robot's decision making.
Thank you. Let's have one more question.
I was wondering for this group if you could share a little bit about maybe what ROS capabilities that you're kind of leveraging relative to your product development, and and if that changes over time as you mature your systems.
Yeah, we're heavily leveraging ROS. I think most of our system runs on a ROS framework. So ROS nodes everywhere. All the communication about the information on the system gets passed through that type of system. We're also looking at the new ROS navigation tools that have come out recently as a way to enhance our navigation, especially for outdoor applications. It would be a long discussion to talk about all the ways that we've leveraged ROS. There's so many. I think it would be difficult to isolate them, but we wouldn't have been able to do it without the ROS technologies for sure.
All right. And I think with that, we've come to the end of the Q&A session for Michael. So thank you, Michael. Let's
Thanks.
give him another round of applause.